you. So we want to look at this together. Apologies, that should have been 15, but it's alright. You get the gist. So let's plot the graphs of logarithm. Now, logarithm is the inverse of what? Logarithmic function is the inverse of what function? If you're speaking, you speak louder, please. Exponential function. Why do I have just two responses? Not everybody remember that. We have done logarithm of base something something in the past in topic 1. Yes or no?
Yeah. Yes.
And we talked about the inverse of logarithm there. You can change from logarithmic function to exponential form into index form of logarithm. You remember that rule? Okay. So this is the inverse of exponential function, which means the two graphs, we have a particular relationship. Raise your hand, please. Mister.
They reflect along y equals to x.
They will reflect along y equals to x. Expected, but let's see. Now, let's focus on the log first, not the inverse yet. So the first question is about that. What happens when we change the base of the logarithm? What happens? That's what we want to see. Okay, I'll show you the implication of this later. So log 2, log x base 2 log x base 3 log x base 10. That's just log 10, 20. This is what you got, right? So let's see. Comment on the significance of A. What happens when that base changes?
You use a 10 for the third one.
Speak louder, please.
You use a 10 for the third one.
Log base 10 is just log. Log by
We did that in
definition is
topic
base
1.
10.
If the base is not indicated, it is base 10. But thanks for noticing that. Yes. What did you notice? You don't have to change what you have done. Whether you put 10 or you don't put 10 is the same thing. Yes. What is the significance of that A? Basically, what happens when you change the value of A? A, of course, is greater than 1. Or I should have said A greater than 0. Or maybe I tested A greater than 0 elsewhere.
Yes.
Okay. So A greater than 1 in this case. Joey, let's start with you.
The larger the value of A, the closer it is to the origin.
The larger the value of A, the closer the graph it is to the origin. That's not the only thing we can notice here. What else do we notice? But that's very good observation, but that's partly the observation. Yes, Miss.
As A increases, the gradient of the graph becomes less equal.
Who can tell me why that may not be accepted, the gradient of the graph? Just that statement, the gradient of the graph. What is wrong with that statement as young mathematicians? Yes, sir, let's try it.
Each point on that graph is different.
Thank you. So when you say gradient of the graph, at what point? So you made it sound like, oh, this graph has a graph, let's say the one in blue, has gradient that is the same everywhere. So you are commenting on that gradient that is common to all parts of that curve. Based on the value of A that you change, the gradient will also change. Even for one graph, the gradient is not the same every point. So that is why that statement will not be accepted. Do you understand the point? So, yes, any other person, but I think I get what she's trying to say. You need to try to rephrase. Yes, ma'am.
If you add on the first quadrant,
Speak louder, please.
If
Don't
I
forget
said-
people are making noise
if
out
I
there.
said on the first quadrant, would it be?
On the
On the first quadrant?
on the first quadrant, everything is always on the first quadrant. Well, except this one.
Yeah.
But put it in another way instead of saying on the first quadrant. Yes, let's hear him then. Nice try.
When the value of A gets bigger, the graph is closer to the axes, the x and y axis.
When the value of A gets bigger,
The graph is closer to the axis. What's the plural of axis?
axis is just axis. Just I change to E. We still pronounce axis.
Oh, yeah,
The graph is closer to.
the axis.
Okay. So regardless, the graph is closer to the axis. When you say the axis, if you look at this one, this is far from the y-axis, even though it's close to the x-axis. So you can't just say it's closer to the axis because it's not always the same. But that is actually in line with what I want to hear. Can anyone put it better? As A becomes large, the graph is, you said here that it's closer to the origin, right? You should have said from this point, and from this point and above is actually closer to the x-axis. As A becomes large, the graph is closer to the origin between 0 and 1. Okay? And closer to x-axis from x is greater than 1. Okay? So if our next one is 30, it will come behind here and it will come below this one. Am I making sense? If the next one is 1/2, expectedly, it should come here and over here. Am I making sense?
Yes.
Like something greater. I couldn't, okay, maybe 1.5. So that we just focus on greater than 1. Please tell me something if you understand or not.
Yes.
Yes.
Does this make sense?
Yes.
Now, what was the next question we answered in that investigation? Oh, that's all about the first one. Okay? So please take note of what we just said. 2 points here. The significance of A is that as A is greater than 1, as A increases or as A becomes large, between x is equal to 0 and 1, the graph moves closer to the origin. And outside that range, the graph moves closer to the x-axis. Not both axes, x-axis. Does that make sense? That is the significance of A. So when somebody gives you 50, you know from here it's going to go that way, and outside this region it's going to come down. And of course, everything passes through 1. I don't know if I asked that question later. But I should have asked, what do you notice before asking the significance of A? Everything passed through x is equal to 1. And that makes sense. If y is equal to 0, x is 1. Y is equal to 0 means whenever everything is equal to 0. If each of these is equal to 0, do you remember the logarithmic law? Right? The base goes to the other side and takes the power 0. So whatever that base is, it's going to raise to power 0. Anything raised to power 0 is what?
1.
That is why they all cross at 1.
Oh.
Does that make sense?
Yes.
Okay, maybe I shed more light on that. In case someone is confused. Joey, can we see this? I'm going to move this book to the board. Can we see it?
No.
No. Okay, just a moment. This is what I'm saying. Log, okay, the base is A. X is equal to some Y. This is logarithmic form. The index form will be x is equal to what? A to power y. So at the x-axis, y is equal to 0. So which means at the x-axis, we are dealing with logarithm of x to base A. A changes 2, 10, 30, right? It's equal to 0. Definitely x is equal to A raised to power 0, which is equal to 1. So regardless of the base, x is 1. That is why they cross. Does that make sense? So don't forget the significance of A and this interesting property. Okay, if your log looks in this form, it's going to pass through x is equal to 1. And the bigger the value of A, the closer to x before it crosses, and the closer to x-axis, no, closer to the origin before it crosses, and closer to the x-axis after it crosses. Am I making sense? It never goes to the negative x-axis. Can somebody tell us why? Based on your previous knowledge in topic 1, it never goes to the negative x-axis. Yes, ma'am?
Because whatever power a is raised to, it would give a value of negative.
Say that again.
Whatever power the a is raised to, it would give a negative value.
It's from here. 2 ways you can defend that. Whatever power A is, even it's positive or negative, 2 raised to power, 3 raised to power, 4 raised to power will never give you a negative answer. Right? And also, that is the main reason the domain of a logarithmic function is from x greater than what? X greater than 0. When we did log, we stated that clearly. A log function cannot assume a negative number. So if you cannot assume a negative number, then you have no business on the negative axis. All these things are connected. Alright? Let's look at the next one. The next one, I said plot the graph of this. Oh, too small. I think by looking at it from your previous work, can somebody tell me what these things will do? Raise your hand. Yanko.
Horizontal translation.
Horizontal translation. Just like every other function, f of x. F of x is a function. F of x minus a means it's going to move a to the right, a unit to the right. Right? F of x plus a means a unit to the left. You have to remember, the general format is x minus. Okay? So when I say x plus a, don't think, oh, plus a is on the right. No, no, no. It's actually the other way around. You have to be careful with that. And similarly, what about number 3? Who can tell us that? Yes? A vertical translation. We've talked about that also before. Can we see this?
Okay.
Is it possible to see both together?
No.
Even if it's a little part. So you don't have to
That's
stand up
better.
again.
Because the height is different. It's
Okay, alright. If you don't mind, thank you. Now, we talked about f of x as a function. What is the transformation that happens to f of x if I write f of x plus k? King. What happened? How can I get this new function from this one? No idea? Ryan? I can't hear you,
Can you repeat the question?
Okay. It's here, not here.
Yeah.
This is a function f of x from what we have done before. This is a new function. So the graph of f of x, maybe the graph of f of x is this.
Yes.
Now I need the graph of f of x plus 2. How can I get it?
Plus 2, would that mean the graph would be translated
Translated where?
upward?
Speak louder.
Would it be vertical translation?
Vertical translation. Did you get that right? By how many units?
Like 2 units?
By 2 units. Do you know what that vertical translation by 2 units means? It means you move it up 2 steps. So the new one should go this way, something like that. That's exactly what is happening here. As long as they are the same. Joey, can we come back here? As long as they are the same. This is log base 2, log base 2x, log base 2x. Okay? Let's combine these two together. Log base 2x Bye-bye. Or do you want me to take a screenshot of this and send to you as a note? Or no need? No need, okay. Like, come on, we're big boys. Okay, I get it. Kelly, don't get angry. I get it.
Kelly.
She's like, come on, we're not that young. Stop doing that to us. Okay, I get it, Kelly. Okay, so this will be x minus 2. Then I have x plus 3. And we can get this guy out. Let's see. The original function is the blue one. The green, because of minus 2 instead of 1, you can see it crossing at 3. Remember, the original function is the first investigation, right? It will pass through x is equal to 1. And of course, you don't need to measure closeness because you're not comparing with any other thing yet. Am I making sense? And it will just go its own way. Okay? Now, for this one, it's just going to move one step here, one step here. And so on like that. Let's see. There is a particular point where you see they keep crossing, so you can't really pinpoint the asymptote. Can you see that? Because it keeps increasing. It keeps increasing. You might think, oh, maybe the asymptote is 4 or 5, right? But if you move forward, it's now on 6.
So is there no asymptote?
Yeah, just vertical asymptote.
I'm talking about this answer. Let's calm down. Okay? You see? It's now moving close to 10. Can you see? It's moving close to 10. Even the graph is tired already. Do you understand that? Okay, let's move on. We'll continue to see more findings. Let's move on.
So Mr. Daniel, can you zoom out again to this graph? Why does it just end at the bottom?
That's weird.
And also there's a break in the middle and then it ends.
That's weird.
Yeah, it's not.
I looked at it on my computer and I was confused.
That's weird. We need to investigate that.
Oh.
Give me a feedback next week. You go investigate that.
Cool.
I never zoom out this way to see. So we need to know what causes this break. Maybe it's a software problem, or maybe there's a property. No, but seriously, this is how you learn. Okay? And I don't have a ready-made answer for that. So we have to figure out why. Is it a software problem? I don't want us to waste time because this is almost 10 o'clock. If it's a software problem, figure that out and let me have a feedback next time we meet. If it's not a software problem, oh, I discovered there's a property of this that led to that. Can I please ask at least one person to come back with a feedback? Okay? Or a team of people to look into that. Please ask questions, but please, if it is not relevant, please just save it so that we do not waste time. So for the third one, so if we go ahead and change this, so I could just take a screenshot of this so you remember what you want to do. Ayah. One sec. Five. Dude, what is that?
Did you read it?
Yeah, I read it
I
and
thought
I
it
was
was funny.
confused. Okay, enough of your stuff. I'm done. So if we close that and close that, so again, it's a vertical translation. Just move up. Okay, just move up and down. So, and of course the intercept will be different this time. Okay, the first one, the intercept is 1, the other one is less than 1, then one is intersecting at 4. Those intercepts shouldn't be difficult to figure out. For example, for log to base 2 of 3, Okay, base 2, x plus 3 is equal to 0. Of course, this will be minus 3, right? So eventually, our x will be 2 raised to the power minus 3, which is 1 over 8. And that's the one that is very close to here, 0.125. So similarly, if this was minus 2, you're going to get that, and you get 4. That's the one here. Okay? So in general, if you have a vertical translation, and this is maybe plus a, so this will be minus a, 2 raised to the power minus 8. So the intercept will be 2 raised to the power minus 8, if you have a plus a. Okay? And if it is minus 8, then it will be plus 8, something like that. So it's a power of 2, basically. Okay? I think we can see that we can make a conclusion from here. So it's going to be the negation of that, but 2 raised to the power negation of that. Am I making sense?
Yeah.
2 raised to the power negation of this. That tells you the intercept. But that's something you can quickly, just write something like this on your paper and figure out. No need to memorize. Okay. Now, the last but not the least. What if the powers are fractions? Those are the ones I removed. Okay. Let me try Anika's badminton method.
Oh, it's easier to just how do you do it? It's easier to just type it out on the side and then copy and paste half into the base.
Like this.
Yeah, and then take that and then copy into the base.
Okay, thank you. That works too. Okay, so we have 1 over 2 base. We have base 1 over 3. Base 1 over 10, 1 over 20. One of them is not necessary. So this should be 3. So tell me what you notice. Now, I want you to compare this to the previous ones. Maybe we can put that on a different decimal. Previously, we had power 2, base 2, right? Then 3, the same set of numbers, but the reciprocal this time. And I need you to tell me something. So this will be 20, this is 10. You don't have to include that. Take notes. This is 3. One sec, please. So this is the one without inverse, and this is the one with inverse. So I'm gonna do the color coding to be the same also. Wait, can we put them on the same graph?
Yeah.
Then we can, check something. Let's put them on the same graph. I'll use the same color. Elsin, stop snipping in my class. Come on. Please, while I understand you guys can be tired sometimes, you need to stop that attitude of coming to sleep in my class. That I accept it doesn't mean it's right. Not that I accept, but I understand. You can be tired. There's a lot of stressful thing going on in your life. Please don't make it a habit. I'm going to change stuff. Just hold on, please. What color is that?
This one's orange.
Okay, so I have 1 over 3, 3, same color. I have 1 over 10, 10. This is red, so I put this for red. Wait.
Blue.
2 supposed to be blue.
Blue, okay.
And I'm saying I'm colorblind. The last one's supposed to be red.
Yeah.
That's not bad.
So let's check one more time. 1 sec, please. 1 sec, please. 1 sec, please. Okay. Yes. Any observation?
They reflected the exact x-axis.
So let's take them one after the other. Can you see that? It's a reflection. Can anybody justify why? From your previous knowledge, why does this give a reflection? Yes, sir.
The base is they're inverse of each other.
The base is what?
They're inverse.
Inverse. The word inverse, what do you mean? Inverse could be inverse. What's inverse? I need, yes.
It means reciprocal.
What?
It means reciprocal.
The reciprocal, yes. Or you can use the word inverse, but you need to add an adjective there. Multiplicative inverse. You can't just say inverse. When you say inverse, are you talking about additive inverse 0? Additive inverse negative negative 2. That's an additive inverse of 2. Do you understand? No. Okay. When we talk about binary operation, which you will discuss here, 2 times 2 is equal to 1. 2 plus minus 2 is equal to 0. 2 has inverses, but depending on the operation. If the operation is times, which is multiplication, I mean, this is the inverse of 2. If the operation is addition, this is the inverse of 2. Because an element with the inverse operated together gives what? Gives what? Is this also 1?
Gives the
An element operated with the inverse gives what? In general, we've talked about that.
I forgot the name.
The identity. Identity function. F composed with F inverse gives X, and X is the identity function. It's a general rule. Did your set do matrices in Form 3? Did I teach you guys matrices? Okay. So you must have remembered, I must have mentioned A inverse A gives I. What do we call this I? Identity matrix. So an element operated with the inverse under that operation, binary operation, is an identity, gives an identity element. Okay? So when you say inverse, you need to be clear. Matrix inverse, function inverse, multiplicative inverse, additive inverse. That is why I pretended that I don't understand, because I'm confused, basically. Okay? So in this case, yes, it's right. The bases look like inverse. And if you look at it in an algebraic way, Joey here, log half x. I want to see the connection with log base 2x. Shall we change the base to base 2 and see what we can get to make it look like this family of functions? If we change the base to base 2, what do I do first to change the base? Don't tell me you're forgetting topic 1 already because we're in topic 2. So when I get to topic 3, you forget topic 2. You cannot, do this for IB exam. How do we change the base of a logarithm? Answer no. Shouldn't be just a few people answering questions all the time. How do we change the base of a logarithm? Yes, Joey.
I think you write it in a fraction.
You write it in a fraction. Yes.
Log to the whatever base you want to change it to.
Log to the base you want to change it to. In this case, base 2.
X on the top and 2 on the bottom.
X at the top and?
2.
Nope. That's 1 over 2.
Oh, sorry.
Guys, come on. This is simple stuff. So if I give an end of year exam, you expect me to only tell the topic you did last time? No. Your end of year exam is everything you have done from the beginning of the year. So this is log to base 2 of x. How do we evaluate this? Somebody else. Not you, Yanko, you have spoken today. The rest of you have spoken today as well. Let's have others who have not spoken today. And you are wasting our time, please. How do I evaluate this one? So if I give a test now on logarithm, and this is the only question, evaluate without the use of calculator, only 4 people will be able to answer. Is that what you're telling me?